So now let's work with something a little bit more complicated. Let's open up another data set. So I'm going to open up File, Open, Data. I'm going to navigate to the desktop where I stored my files. And I'm going to look for, now you'll notice that right now I see a cell series. Oh, you want to know something? There's data from last semester on here. I see a whole series of these SPSS files. I can see them because right now it's looking for, if you look under here, files of type .sav. It's looking for SPSS data files. And there's a whole bunch of them. I think the one I said probably is one of these over here. They're probably all the same anyway, right? Probably all hangovers from the same thing. Okay, so I'm going to highlight that. I'm going to hit enter. But before I do that, I'm going to click down here, and you'll notice that SPSS can open a whole series of different kind of files. For instance, it can open, let's see, let me see in Excel files. Here's Excel files over here. I'm going to click on that. Notice the SPSS files are not visible anymore, right? So if you don't see the file you expect to see in the folder you're looking for it, it's probably because it's set for the wrong file type, and it won't show it to you until you get it to show it to you. So now you can see that there's a whole series of Excel files here as well that we didn't see before. Okay, and there's any number of other kinds of files. You can exchange files between SPSS and SAS. You can exchange files between various database programs and so on and so forth, and even text files. Remember those .csv files? They're included down here. If I go down to all files, then you see everything that's on the desktop, all the different kind of file types. Okay, so I'm just going to open up this NC Birth 800 mod, whatever that stands for. And we get a new data window, a fresh new data window appears, right? And the first variable is plurality. Anybody know what plurality means in birth data? Number of infants born, number of babies born during that birth. Right, twins would be 2, plurality of 2. Sex, that's the sex of the infant, obviously not the mother. Image, what is that? Yeah, maternal age. I'm sorry, you're right. Well, you want to know something? What just happened to me there? I didn't understand the variable name. Why is that variable name look like that? What's an abbreviation, right? They can't put maternal age because it's got space in there. So let's go to our variable here. Okay, so let's see. If you look in here, someone has already gone through this and defined labels. MH is age of the mother, right? Let's see, also for sex, the values for gender have been assigned, 1 and 2, just as we had done it before. Someone has done this before. That's called coding. Someone has coded these variables, so SPSS understands what kind of variables are, which are nominals, which are scalar. Age of the mother is scalar. The amount of weight gained is scalar. The weight of the, I think there's a few variables that the weight of the infant. There you go. Yep, in ounces, and weight of child in ounces, and the weight of the child in, yeah, now you can go up here and spread these out a little bit, just like weight of the child in ounces, weight of the child in grams, and so on. So I'm going to go back to the data view. Okay, so now, and we have various other kinds of information here. For instance, whether the mother smoked during pregnancy, whether the mother drank during pregnancy. And again, these variables are coded. It could be 0 and 1, could be 1 and 2 or something like that. If we want to know, go back in the variable view, take a look, and where is drink, right? And in that case, 0 represents the mother did not consume alcohol, 1 represents she did consume alcohol. So back to the data view again. Okay, so I'm going to give you guys a chance to try this. And then I'm going to give you 10 minutes to, let's pick a variable out. Let's see, give me the average, give me the descriptive statistics for the average age of the mother. Okay, I didn't say, to break it down, factor it by anything like that. Just whatever descriptive statistics you have for the age of the mother. And maybe you can give me a histogram as well. You guys okay over there? You having problems with the machines?
My license ran out of this.
Okay.
Yeah.
Is there another thing? Wow, I didn't expect this many people here. Normally, you guys ditch us after the first, and once you know you can stay home. I guess the weather's good, so it's perfectly okay for you guys to bring your laptops if you want to. That's probably going to be true for the tests also. Okay, you guys were able to download the data files? I hope. I'll give you a few minutes to work on that. Okay, in the meantime, I'll go into the chat over here and see if the guys at home are still functional. Okay, guys at home, are you okay? Are you still there? Okay, good, excellent. So hopefully, if you have it, if you have SPSS, you'll be able to give this exercise a try. Also, after these guys get a few minutes to play around with it, I'm going to repeat the exercise myself and do it myself. So you'll be able to view it. Yes.
Is GoToMeeting used for both the lecture and
No, the lecture is using Google Hangouts or Google on the I think it's called Google on the Air.
Okay.
It's a broadcast system, so that if you go to that same YouTube, that same site, I think it's like like YouTube, something, and then it's got PH751.
And it's on this on Blackboard.
It's on Blackboard, yes.
Okay.
Do you have access to Blackboard?
I do.
Okay.
Thank you. Also, it's retrievable after.
Oh yes, absolutely. It's a meet. In fact, not only is it broadcast live on there, but it's immediately available. Right? You don't have to wait for it to be posted. Not only that, but as the lecture is going on, if you're at home, as the lecture is going on, and you say to yourself, "What did he say?" You can actually scrub backwards and listen to it again. It's actually interactive, so you can, like a VCR, like a DVR, you can scrub backwards.
Can you open the file and put it into iTunes?
I'm sorry, say again?
Can you open the file and put it into iTunes? It's the option.
Yeah, just talk louder.
It's the option to open the file and put it into iTunes again. So like how
Oh, you download YouTube. That's a good question. I don't think you can download it, but I'll check. Okay, I'll find out though. Now, the lab sessions are done using GoToMeeting. Okay, the reason why the lab sessions are done using GoToMeeting is because you don't see it when you're working here, but there's because the trade-off for being able to scrub back and forth and instantly have it available is that there's a lag. So when I see the meeting end here, it actually ended 2 or 3 minutes earlier. And that lag would get in the way for my using software and working interactively with people online and stuff like that. That's why I use GoToMeeting instead. The downside of GoToMeeting is that I have to take the video file, convert it and upload it to YouTube. So it's not available for about 24 to 48 hours until I get a chance to do that. Right, but that you for sure can be downloaded onto your own computer if you want. You won't see an option to download it on YouTube, but there's utilities that you can install on your browser that when you go to that web page and play that video, then you can just go up to a little link on the top of your browser and say, capture that video for me, it'll download it. It's not protected in any way. Right, so you can do that. I believe you probably can with the Google Hangouts one also, but I'll check to see what you have to do that. Oh yeah, I understand. You want to be able to watch it offline. Yeah, of course.
No, I want to be able to watch it on double speed.
On double speed? Oh, okay. Yeah, you can do that for sure. Between me and you, I can understand that it's easier to stay awake when we're talking fast. Right?
Let's pause it.
Yeah. Is it possible to customize the bins and the histograms? Yes, it is. I'll get to that as we move forward. I'll get to that. Right now, it kind of makes its own analysis. It distributes the bins in a way that it thinks will give you a readable histogram, especially if there's very little data. It kind of makes a wacky judgment on how to do it. But yeah, we'll get to that. Not right now, but we will get to that. Okay, I see like most people seem to be progressing okay. Okay, I'm going to do this exercise myself. And I'm going to analyze descriptive statistics, descriptives. And since I'm interested in numerical variable, okay, I'm going to go in here. I'm going to look at the options. I'm going to ask it for all this stuff. Why not? Okay, and I'm not going to worry about the rest of this stuff because we haven't really covered that yet. And I'm going to click OK. And here we go. I get an average age, an average age of mean age of 26.92, about 27. I don't see a median there. Apparently, this doesn't give me the median. Minimum of 15, maximum of 42, standard deviation of 6.107. Now, I'm going to go back there. I'm going to say analyze, descriptive statistics. I'm going to go into explore this time. And even though I'm not going to use the factor, I'm going to move this in here and ask it to do these statistical calculations for me. Okay, it's already set up for descriptives. I'm going to ask it to do a histogram for me. And I'm going to say continue. And I'm going to say OK. And this time it's going to give me a bit more information. It's going to give me the median, the mean, confidence interval, we'll worry about that later on, variance, standard deviation, minimum, maximum range, interquartile range, and so on and so forth. It gives me a histogram for the weights of the mothers. Okay, does that look skewed to you? If it's skewed, what direction is it skewed? To the right, or that's called to the right or positively. And why do we say that? Well, because imagine that this is a perfect bell curve, right? It's symmetrical. Perfect bell curve is symmetrical. And the mean and the median are exactly the same place, right? So let's say you get a couple of people that mothers who are unusually old. They're all you have a couple of mothers that extend out a little bit further, like we do in this case. Well, if we took those two away, the median wouldn't change much, right? But if we took those two away, the mean would change quite a bit because those high values tend to pull the mean away from the median, right? And which way is the median going? The median's staying there or moving only slightly, but the mean is getting pulled away from it. If it's getting pulled up, that's called positively or right skewed. If it's getting pulled down the mean away from the median, that's called negatively skewed or left skewed. Okay, and so give you an example. If you guys all leave this class, who's the tallest person in this class? We don't have anybody like 6'5" or anything like that, right? Let's say you all go out into the field and we look up what your average starting salary is after you get your master's degree. And we have 60,000, 70,000, 80,000, 90,000, 40,000, so on and so forth. Somebody joins the Peace Corps at 15,000, right? So, but we got somebody who's got a salary of 5 million, right? Well, maybe they went to play for the Knicks or something like that, or the Nets, right? Who knows, right? But they would skew this distribution. The median wouldn't change, right? Because the median is the middle value. So that $15 million person is not going to change the median value, but it's certainly going to change the mean dramatically. So it's that's what we're really looking for. It's how it skews the mean away from the median. Okay, so that's our, and there's our stem and leaf plot. Notice our stem and leaf plot really looks a lot like in this case where we have some decent data to look at. It really looks a lot like our histogram turned on its side. Okay, and if I wanted to, I'm surprised they make a box plot. Oh, there it is. There's a box plot. And again, we got lucky. We have no outliers again. Here's the median here. Now the median looks like it's closer to the lower numbers than it is the higher numbers. That shows you that this is skewed positively or skewed to the right. That median should have been in the middle, basically the same as an average, right? In between these feathers or whiskers, right? So we can see that that's not in the middle. There's a slight skew here. So these box plots can give us a little bit of a hint of what's going on. Okay, next thing you're going to do is we're going to take a look to see if there's a difference in the weight of a baby born to women who smoked during pregnancy versus women who didn't smoke during pregnancy. So we're going to have to get a little creative with that. I'll give you guys a chance to do it on your own first, So if you see if you can figure out how you would do that. In other words, you want to find the means of the birth weight of the babies of women who smoked versus the birth weight of the babies of women who didn't smoke. You want to take that variable birth weight of the baby and break it up or factor it into two groups. Okay, so I'm going to leave that up to you guys to give that a try. Are you guys okay with it? Oh, yeah, I have problems with computers. Oh, okay. You don't have, oh, the box plot comes off automatically when you do explore. It won't appear when you do descriptive statistics. But when you do explore, descriptive statistics explore, it'll come up automatically. There you go. There it is. Yeah. You can. You can do it under that legacy dialog.
That's right.
Yeah. Let me we'll play with that. Yep. Okay. Let's go to that box and then over here. Okay. That's great. It says we can just say okay. And there's the 7 week going. And it's going to go to okay. So now let's go back through again. Analyze. Statistics, explore. Okay, so this time it's doing plots. And this time we collect histograms. And say, okay. This time we'll also do histograms. There it is. It was there. Yes. Yeah, if you want to know something, normally most of these are installed, so it gives you all of those options. I would say case special, you see all the options. Right, so by default, I would normally, if you do it at home, it would normally be something that have those all checked off. So that when you say case special, you have all those choices. Yes?
I kind of lost you before.
Okay. The dependent is the numerical variable. You want to get that, the factor, that would only be your nominal variable. Like if you want to divide it up into two groups. If we want the age of the mother, we would put up here. Okay? If we go into statistics, it's already got this there. Okay, so that's set. Turn that off. Over here, plots. Okay, let's do it this way. And say continue. Okay, that says both already. That's good. Let's click OK. So now it's always, when you do explore, it always does a box plot. So now it did this for us. It did this for us, the age of the mother, the average age of the mother. Scroll up. And a box plot is down there somewhere. There you go. There's your box plot. But that's the age of the mother, the distribution of the mother. Okay. Now you're going to get a little more adventurous. Let's go to explore. Analyze. Statistics. Explore. Okay, now this time, let's get rid of that. We need to click on that, get rid of it. This time we want the weight of the infant to go in there. Either one, there's two of them, allergies and grams, doesn't matter which one. Okay, now this time we want to break it up into two groups. Which groups we want to break it up into? Well, whether or not the mother smoked. So let's see, smoking. That's the benefit. That's a nominal variable. See, that's nominal. Names, that's a scale. So it's going to break this, these statistics, we're going to break it up into two groups. Okay. Right. Okay, so let's go. We already set all this up, so let's just click OK.
Oh, we don't have to do non-smoking?
No, because it does. See, it's already in there. It's in the variable. 1-0 is smokers. 1 was the other way around. 1-0 is 1. Was non-smoking. 1 was smoking. right? So that's in there. So now it's going to break this up into those two groups. So if you click OK, there you go.
Oh,
Right?
okay.
Scroll, you'll see some more. Right? Everything now is done separately for the two groups.
Okay.
Okay, cool, right? Okay, so let's give this a try. How you guys at home doing? They seem to be okay, right? Okay. Okay, I missed something on the chat here, I think.
So this lecture is going to be posted on Blackboard?
Yes.
Okay,
Yep.
that's how.
Okay, we'll do it again. You'll be able to get to it again. Okay, so now I'm gonna do very much what I did with that smaller file. I'm gonna go to Analyze. I'm gonna go to Descriptive Statistics, Explore. Okay, well, the comparison I want to make now is I don't need the age of the mother anymore, but I am interested in the amount of weight gained by the infant. Now, the data file I'm using, I think, is a little bit different than yours, but I'm going to use ounces. Okay, that's the amount of weight that was gained by the infant in ounces. You could use grams, doesn't matter. And the factor list is going to be whether or not the mother smoked during pregnancy. So I'm going to take smoke. I'm going to move that into my factor list. So what's happening here? First thing I can see is that my dependence list, the thing that I'm actually going to do my statistics on, my analysis on, is a numerical variable, which it has to be. Mean, median, standard deviation, all this has to be a numerical variable. So that's the weight of each one of these infants in ounces. So I'm going to get an average weight for these infants. Now the factor list is those analyses are going to be done twice. They're going to be broken up into whether or not the mother smoked versus non-smoking. Now, had there been 3 values in here instead of 2, in other words, smoked more than 3 packs a day, smoked between 1 and 3 packs, or non-smoker, there were 3 groups, it would make 3 histograms and find 3 averages and find 3 standard deviations and so on and so forth. So I'm going to go into statistics, make sure it's going to do my statistics. Yes, that's checked off. 95% confidence interval. You don't have to worry about that for now. And I'm going into plots, and I've already checked off. It remembers from the last time you did it. When you quit the program, it'll go back to its default values. But as long as you don't change them, it'll keep going back to whatever you did with the last analysis. It's going to do histograms as well. We know it's going to do a box plots for us automatically. It's going to do something interesting with the box plots, which those of you that have completed this have already seen. Okay, and we got some options. I'm not going to worry about them. And I want to make sure it's clicked on to give me both the statistics on the plots. I'm going to click OK. Okay, so here's our analyses. So let's compare them. The mean weight of, I think this is ounces. The mean weight of mothers who did not smoke, of the infants and mothers who did not smoke during pregnancy is 117 ounces. The mean weight of babies of mothers who did smoke during pregnancy is, get away from there, is 109 ounces. There's a difference there, right? There's a whatever 8 or 9 ounce difference there. I don't know if that's clinically significant or not. Now, I'm not even sure whether it's statistically significant at this stage because I haven't run various tests to see. And now, remember this, there's 2 groups here. Let's say that there was, in real life, there was no difference between these 2 groups. In fact, let me make something up, like for instance, let's say the 2 groups were mothers who arrived at the hospital wearing red, and mothers who arrived at the hospital not wearing red, something that would have no bearing on what the weight of the baby is going to be. If I found the mean of those 2 groups, it's not going to be the same number, right? Sometimes the first group will be a little higher, so it's going to be different numbers. The real question is that difference big enough for us to say with some level of confidence that the difference is not due to just plain chance, that it's really due to a difference that was caused by that factor, by that smoking, okay? And that's what we're doing. That's what we're going to spend the rest of the semester doing, trying to figure out whether the differences between these groups, between these values for these groups is real, or if it's just occurring by chance. You know, just because anytime if you took the same measurement twice. Personally, when I go to the bank and they give me money in an envelope and stuff like that, I take it out and I count it, I get a different number every time I count it. But that's just me. You know, there is a certain real value there. Problem is that with the me, there's a shot I might eventually get the real value. When you do a sample, you're never going to know what the real population mean is. All you're ever going to know is what your sample tells you, right? So if we knew what the population mean would be, we'd never have to do any of this stuff, right? We wouldn't need it because we already know whether the population of mothers who smoke has different weight babies than the population of mothers who don't smoke. In here, we've demonstrated that there's a difference between mothers who smoke, a sample of mothers who smoke versus a sample of mothers who don't smoke in North Carolina during this period in this particular hospital, but we don't know if that's true for the entire population of mothers in North Carolina. Right? But that's really what the key is here. That's really what we're trying to do, is figure out whether or not this, number one, whether or not this difference is real, or if it just occurred by chance because of the way we sampled and took the average, or also whether or not it's clinically significant. Does it make a difference of whether or not babies are 7 or 8 or 9 ounces different? You know, so, and you can draw your own conclusions about it. You guys know more about that. I'm an EOHS guy, so most of you guys are going to know more about that than I will. All right, so that's really what a big part of this is. And in fact, the 95% confidence interval, now that keeps coming up, we said it about 12 times tonight. Might as well just look at it briefly now, even though we don't have to understand it right now. The 95% confidence interval tells us, well, the mean from this particular sample came out to be 117 ounces for mothers who didn't smoke during pregnancy. Well, the 95% confidence, based on the variability that we see in the sample, the weights of all the different babies, how variable they are, we can run a statistical test that tells us that we're 95% confident that the true mean of that population, not the sample, the population, is between 116 and 119, right? Okay, let's take a look at the mothers that did smoke. The 95, we think the mean is 110 ounces, right? But the 95% confidence interval tells, but we don't know what our level of certainty is there. But the 95% confidence interval tells us that the true mean of that population is between 105 and 113. The other one was 116 to 117. This one's 105 to 100. So there's a difference between the two 95% confidence intervals. It's very tempting to say that since the confidence intervals are different, they don't overlap, that we can be 95% sure that that the populations really are different. That's a bad thing to do. I don't think it's that bad, but real statisticians really think it's bad. Okay, to use confidence intervals like that as a predictor. Confidence intervals just give you the level of certainty, the range within, based on the variability and the mean that you have of the sample. The range within you can have a 95% confidence that the true population mean lies. And that's got a lot of that's tied into the sample size. If I took one sample and that sample came out to be 100, yeah, that resulted that if I sampled one thing and the value was 100, I have no idea how variable that is. I don't know if I took another one, if I'm going to get 10 or 99. I have no idea. If I take two samples and one is 100 and the other one's 90, well, now I'm starting to get a look at the amount of variability. Not very good, but a little bit of a look. If I took 3 samples, 100, 90, 105, now I'm getting a better feel for how variable these numbers are. So I'm getting a better idea for where the mean might lie for this true population. Bigger the sample size is, the narrower that confidence interval is going to wind up being. So in other words, makes it easier for you to get a narrow range of where the true population mean is likely to be, 95% certainly to be. Okay, so that's important. That's what we're going to be working with. I bring that up personally because I do mold spore counts. Anybody ever done mold spore counts? Or been involved like mold testing or what do you guys? How many of you guys are nutrition majors? How many of you guys are epi majors? Okay, mostly epi majors, eh? Okay, what's the other majors? What's left? Biostatistics. Okay, so you guys don't do real work. You're you do research, right? So in the world where we do real work, people call up, oh, I think I'm dying from mold in my apartment and stuff like that. It's popular to do mold spore counts. Mold spore counts, they take a pump, sucks 15 liters per minute of air through this pump, suction pump. Makes a lot of noise, and you put a cassette on the end of this thing, so you're sucking air through this cassette. This cassette is a little sample, a little plastic sample, disposable. It sucks air in. Inside of that, there's a little piece of glass with sticky material on it. So any particles that are in the air get stuck to that as it gets sucked through this device. So you run this at 15 liters per minute for say 10 minutes, and you take whatever particles that are of that size range that to be able to be pulled into this thing. They get pulled in, they get stuck to that little plate, so you know that's how many particles you have in the air of in 150 liters of air. Now you take that, they open it up in a lab, and the microbiologist looks at it and actually counts. A lot of that's going to be dust, hair, roach feces, skin cells, you name it, all sorts of disgusting stuff. Some of it's going to be more pollen, some of it's going to be mold spores, and they'll count the number of mold spores there. And you might say to yourself, "Oh, gee, I want to use, I want to make sure that this area is safe. I'm going to do a test like this." The problem with that is a lot of people do that, and it's expensive to do these tests because the microbiologist got to read them and so on and so forth. And they might do 3 or 4, 2 or 3 or 1 or 5 or something like that. Problem with it is it's so variable. If you did one now and you got 100, you might want to do one a half hour from now in the same spot and get like an order of magnitude different, get 500, get 1,000 or 2,000 or something like that, and go back and get 400. They're so variable that the value of it, a couple of tests doesn't really tell you, where the real average is in that air. So a lot of people use them comparatively. They test this area and this area. Problem is that you can't really depend on when you only take 2 readings, since they're so variable, you can't really rely on them that much, because you can imagine the confidence interval is very wide. The real number of average mold spore in that air might be 95% confidence interval might be 10 to 5,000 or something like that. It's not a very useful measure. They do them anyway because people insist they love testing. Right? Fortunately, the levels outdoors are dramatically different usually than they are indoors, unless you got an immense problem. But if it's bad enough to pick up with mold spores, you probably see it growing out of the walls and reaching out to grab you as you go by. But that's the whole thing. When you take measurements, the number of measurements, the variability of the measurements, they all tie into this idea of what the average measurement is. So it's important that we understand that there's a relationship between these means and the variability of the data and the level of confidence that we have in taking that mean and using it to predict what the real mean is of the population is. Okay, so let's scroll up through here and see what the rest of the stuff that we have here. Okay, descriptive statistics. Where are we? Oh, you know what it is? I notice while I'm at this, somehow or other I got to the top of this thing. You literally, everything that we've been doing today is stored on this output window, right? And in fact, if I scroll through this, it takes me a while to get to the bottom of it. You'll notice that there's a sidebar over here. And this sidebar has links to each one of these things. So if I want to go down back to the most recent analysis that I've done, I just need to click down there and it'll take me right down. It's kind of like an index of all the analyses that we've done. Okay, so here's where smoke during pregnancy. Okay. Smoke during pregnancy, let's see, 684 mothers did not smoke during pregnancy. Obviously, nowadays, this actually is a little bit old. So it's not that surprising that you had 100 mothers that did smoke during pregnancy. Here's our histogram for the weight of the child. Now it's skewed. Which way is it skewed? To the left. Why is it skewed to the left? Because you don't get many 80-pound babies, right? It's not unlikely to get skewed to the right, but you do get a lot of premature births, a certain number of premature births. So it's not surprising that this kind of data is naturally going to be skewed to the left or negatively skewed. This is for mothers who did smoke during pregnancy. No, it's interesting enough. There's only a few that were really premature here. But the average, we saw already that the average was lower. You get a little bit of data thrown into this histogram for us as well while we're at it. 117 is the average, and we saw here that 109 was the average. Here's our 2 stem and leaf plots. Here's our side-by-side box plots. And here's the effect of that skew. Notice how many outliers we have here. So many babies that were so far away from the mean that SPSS is warning us that you may want, if you're doing a comparison, you have to decide whether or not these differences are so great that they represent something that's really not part of what you want to look at. And you can see where the median is and where the mean is and so on and so forth. With the outliers excluded, it looks pretty normal, right? Look, the median's right in the middle there. The median's right in the middle. But if you included if you included these outliers, this would look quite different, right? So, and you can adjust what it considers an outlier and what it doesn't consider an outlier. But by default, anything that's more than 1.5 times this width, the interquartile range, 25th percentile, 75th percentile, anything that's more than 1.5 times that from the median, the original median, is considered an outlier. Okay, were you guys all able to do that? Did it work out for you okay? Okay, let's try another one. Oh, I'll tell you what, we only have about 15, 20 minutes left. I did want to show you a couple other things. First and foremost is, if I want to save this output, I'm going to say save as, I'm going to give it a name, and I'm going to go to, for our purpose, I'm going to go to the desktop. And I'm going to save. And now I'm going to close this if I can. Okay, now here's my data window. I close my output window, close my output window, I still have my data windows open. So if I want to save this, if I've done any work here, if I want to save this, I have to go here, File, Save As, and I can give it a name, it'll save it as a .sav file. So if I've modified this data, if I've added data to it and so on and so forth, I want to save it. And you got to save the window separately. Save one, if you close the program, you don't save the other. Yeah, that you won't have whatever you I wound up with at that point. Okay, so now let's take a look at something else you might be interested in doing here. You can take this data and you can export this data. I'm going to say save as, and you can take this and instead of saving it as an SPSS file, you can save it as an Excel file. And I'm going to drop this. Notice it gives NC birth weight, parentheses 3, parentheses 1. I can actually change that. I'm just going to change that. The NC birth, so we can see that it's really there. And I can say save. Save. Okay, saved it as an Excel file. Okay, that didn't save it as an SPSS file. Saved it as an Excel file. Okay, so now, in the background here, in this output, let me open the output I just saved. Open, output, and desktop. It was this one. Okay, I can recover this. I get it back here. Notice that every time I did an analysis, it put this scribble down here, put some text down there. That is the syntax. That's the written instructions, the code that tells SPSS to run this operation. So frequencies, the word frequencies, variables equal gender / order equals analysis. That literally, if I take that and I open a syntax window, paste it in and tell it to run it, it will produce that same analysis. Same thing here. Anytime you open a file, graph /bar, parentheses simple equal count by gender. Those instructions will produce this graph.
But only from that specific data
Only from
set.
that data set, right. Now, if I open another data set and I use that, but it had gender in it, with the same variable name, it would use that also, right? But it would do it with that variable, okay, and so on and so forth. And you can see some of them get more complicated, right? Examine variable, examine, which is explore a variable equals weight by gender. Split it up in those two factors. Plot, box plot, stem leaf, histogram, compare groups, blah, 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 so on and so forth. All those instructions are text instruction that SPS understands. At some point, you might want to use those instructions instead of using the drop menus. There's a few reasons to do that. One of the reasons, if you go into the help menu, you can ask it to give you, like in Excel, you can ask it to give you all of the different specifics of the function plot. You can say, you can tell me about plot. And there may be things in these various functions that SPS, first of all, number one, there may be functions built, I would think relatively obscure functions, certainly not ones we're going to worry about. There are functions in Excel, in SPSS, that are relatively obscure, that are not accessible from the drop-down menus. There are options within each one of these variables that may not be accessible from the drop-down menus and the little summary boxes that you get. So if you really are sophisticated in using SPSS, you might prefer that because you'll have access to more options by using these syntax commands, more ways to manipulate the data than you get from the drop-down commands. For our purposes, for at least most of the semester, we're going to be perfectly happy with the drop-down commands. They're not anything you're going to have to use syntax for, unless you want to learn it. Now, the other thing that's interesting about this is that if you have an Excel file, you can bring it into SPSS. I'm going to click on File, Open, Data. And you guys may remember that one of the things we saw was when you first open it, all it shows you is the SAV files. And I'm going to instead, I don't want to do this yet. I want to show you the file first in Excel. I'm going to minimize this. I'm going to minimize this. I'm going to minimize this, and I'm going to minimize that. Okay, so let's see. Let's find an Excel file here. Okay, let's open that one up. Oh no, that's my document file. I never actually got around to using the document. It was easier just to talk. Descriptive statistics, exercises. Let's open this one. Okay, this was an exercise that we did last week, right? Problem with this file is that there's all sorts of gibberish all over this thing, right? There's all sorts of extraneous data and information and stuff like that, and files and stuff like that. The numbers I'm interested in are over here. This isn't going to be a very easy file for SPSS to understand. What I want from an Excel file is a data set that just lists the numbers, or maybe the variable name in the numbers. To see if I think I should have one here. There's one here that's called Excel to SPSS. It's already set up to do that, to work correctly. Exercises. NC birth. Statistics. Here we maybe that's it. Nope, that's not it. Maybe I didn't save it.
I think it's on the bottom, like that one. It says Excel.
Does it? It's the exercise. No, it's the exercise one.
NCB birth next.
Yeah, well, okay, I'll open that one. For our purposes, that should be good enough. Okay, so now here's the NC birth data as an Excel file. Okay, so the first column is my first variable, the plurality. Second column is my variable sex. Third column is my variable mother's age. Fourth, week, I guess weeks of gestation, marital status, et cetera, et cetera. Now, notice that this is just a plain flat Excel document, right? But this is data that might be valuable to bring into SPSS. Now notice the first row here has the variable names on the top. Not always going to be true. In this case, it has the variable names on the top. So now what I'm going to do is I'm going to close this file. It's called NC birth. That's the one, actually, in fact, it's the one I just saved. Okay, I'm going to go back to SPSS and close this thing. I'm closing it for a reason. I want to take that Excel file, just as I would any other Excel file, with the data stored in the same manner. Each column is a variable. Top of the column has the variable name. Okay, remember, variable name can't have any spaces, special characters, right? We've got to start with a letter. Okay, so I'm going to go into SPSS. Okay, any one of these things. I'm going to say open data. Okay, and I'm going to tell it, well, I want to import, or I want to open an Excel file. So I'm going to change this to Excel. And here's my NC birth data, XLSX, right? That I want to import that data. I'm going to highlight it. I'm going to say open. The dialog box is going to come up. And the dialog box is going to say that I see data in the cell. Sorry about that, guys, online. It's a shocker. That woke a couple of people up. Okay. I'm not going to, I'll just point at it with the pointer. I see data from A1 to O801. In fact, there's 800 lines of data here. That's why it says 800. And there's whatever O is, I guess like 6 to 18 or 19 columns or variables. So that makes sense to me. Now notice there's a little box here that's checked off right now. Read the variable names from the first row of data, right? If I uncheck that, it's going to think that first row is data. It's going to import it as if it's data. If I leave it checked, right, now it's going to realize that that's not data. Use that for the variable names. And you have 8 rows, you have 801 rows, but only 800 rows of data. That's what I want. Now, had that not been had that not been a row of variable names, if the first line were actually data, if I had this checked off, it would take that first row, whatever it was, a number, a name, or something like that, and use that as a variable name, and you would only have 799 rows of data.
Is this the first line doesn't look like it is data?
Oh no, yeah, no, that's not the file I'm importing. The file I'm importing was the Excel file, the NC birth file that I had opened before. Okay, so I'm going to click OK, and it's going to go ahead and import that. Okay, and you know, if I go back to when I go to an output window here, the output window is going to show. Let me see the most recent output window. Nope, not that one. One of these output windows. I'll find it eventually. It's going to show that actual action of importing, opening and importing it. Show the file path and show it importing in the syntax. Okay, and here we go. It realized what these variable names were. It put the variable names at the top. It imported the data. It put in all these numbers. In this case, this is a nominal variable. It's ones and zeros. Right? If you go, it's ones and twos or threes. Gender is ones and twos, so on and so forth. Month's age is a numerical variable. Now, what's the downside of this? It imported the variable names, but what does it not know? Remember all that information that we had about the variable types, about what the numbers represented, and so on and so forth. I'm going to go into the data view. It's all gone. I have to go in there and code it from scratch. Tell it what all those values, which ones were nominal variables, which ones are categorical variables, what does 1 represent or 2 represent for smoking, and so on and so forth. All that information is not imported from Excel. Excel doesn't have that information. They look alike. When you open them up, you have a window that looks like a spreadsheet in both cases, but they're very different programs. Right? In Excel, those little boxes really have more function than they do here. Here, those little boxes are just places to put numbers or values. Right? Columns represent variables. Rows represent cases. Cases could be patients. Cases could be measurements. Cases, multiple count could be rooms, and so on and so forth. There could be any number of things. So if you keep that in mind, you keep a view of what this really is telling you when you look at this, what the output window is telling you. This program is really going to be pretty useful to you. So now I'm going to be posting homework later on. I'm a little delayed because I don't have SPSS running on my machine because they have one person in the whole school that can install it on faculty laptops, and he makes he has a studied hat. Yeah, anybody read Catch-22? So you know that, remember Major? What was the deal with Major? When could you see Major? You could only see Major when he wasn't in. That's this guy. Right? The only time you see the guy is when he's not in. And so I, to track him down and get him to install stuff, it's been like an epic journey for the last 3 weeks. But by next week, hopefully, I will have that. But tonight I'll be posting like a homework assignment. Yes.
It does become easier though with the technology.
I'm sorry?
Not seeing someone when they're not in.
Yeah, exactly. If you haven't read Catch-22, it's really, it's kind of a classic novel. I don't think it's got the kind of the popularity it had, like a few decades ago. But there's a lot of interesting issues. There's a lot of interesting things that like make their way. A lot of interesting observations make their way into real life. You know, so I tend to refer to a lot of stuff from it. So it'll probably come up again. Okay, so I think we're okay. We're just at about 7:50. I just wanted one more thing here. I don't know if I have it here, but I'm gonna, like I said, I'm gonna try and set something up. I'll give you links on R, and I'm gonna see if I can't set something up where we spend like maybe a half hour, an hour online over the weekend sometime, and like we go through the same exercise using R. And I'll record that. You know, I'll probably wind up scheduling it at the last minute, so maybe not easy for you guys to sit in on, but I will record that. See, the last open data file, it asked me to make sure you want to proceed because it's going to close everything. No. Okay, and I just want to show you R in here if you got to stick it. I won't bother. You open up R, it's just a blank window. You open up R Studio, it's like three or four windows will open up. But I'll get into that online, and I'll give you some links where you can go to it if you guys insist on doing this the hard way. Okay. Okay, this is pretty easy, right? So, and if you haven't gotten SPSS, if you plan on buying it, try and do it soon, because the sooner you do it, more practice you get with it, right? It's like you can watch somebody ride a bicycle, but nobody ever learned how to ride a bicycle by watching somebody do it. You do it by getting on the bicycle and actually using it, right? Okay, guys, good night.